Hello everyone and welcome back to Integration Ninjas. Today we have an exciting tutorial for all you GoLang enthusiasts out there. We are going to walk you through the step-by-step process of deploying a GoLang application on AWS EC2 instance using GitHub Actions. This is fantastic way to automate your deployment process and make it more efficient. We will leverage the power of Docker and GitHub Actions both together. So if you are ready to take your Golang skills to the next level, let's dive right in. So what we are going to do, we are going to create a workflow in our GitHub repository where we will define two jobs. One is build and another is deploy. In the build job, we'll create the runtime environment variables for our Golang application if required from the secrets. Like suppose we have some database configuration and the other configuration that needs to be provided to our Golang application, we'll write that secret details there and we'll build the Docker image and we'll push that to Docker Hub. And then after that, deploy job will be triggered once this will be completed, and that will be running on the AWS EC2 system. We will configure that runner. We'll see how we can configure there. We will pull the image from Docker Hub and we'll run the Golang application as a Docker container. Okay, so let's see how our Golang application is look like. This is a project repository. We can see this is the main.go file here, and we have all this information. This is the main.go. We have some couple of things here. We have couple of APIs. So let's try to run this application and see what are the APIs available here in this project. Okay, there are like listen TCP 4040 and just already in use. Okay, probably I have already started my Docker. So let me just delete this out. The port is already in use, so I can try it now. So we can see the application is something like this. It has some APIs, hello from Golang APIs, and we have one more API which is random user, which provides some random details, and we have one more API which provides these details like item details. So we have these APIs, and we have these files like go.mode, like which has all those required dependencies that our project needs, and go.sum will have all this checksum details like whenever the project is been, like we have added these dependencies. So these are the things are present here in this application. So let's try to write a Docker file for this application now. Okay, so I'm going to write a Docker file out here. So in the Docker file, what we are going to do, we are going to define a stage like this is the normal one stage application only. So we are going to define one image which will be Golang, and we are using the Golang 1.22.2 in my system. So you can use any go.1.18 or 1.21, any other as well. So I'm going to use this since my version is this one, and I'm going to use this alpine image, so the image should not get the larger one anyways. And then once this is completed, what we are going to do is we are going to define the work directory for our application, which is suppose slash app. And then what we are going to do is we are going to copy the go.mode, and then we are going to copy go.sum files from the host machine to the slash app directory in the container. Okay, let's give it as like dot slash only. And once this is completed, then we are going to run one command which is go mod tidy, which will download all these module dependencies and that is present in the go.mod and the go.sum. And once this is completed, we are going to copy the all the files from the current directory on the host machine to the slash app directory in the container. So this is look like this. And once this is completed, then we are going to We'll build the GoLang application with this command, run go build -o main, then /main.go. So this -o like main specifies the output binary name as main. So if we run this command, the output binary will look like something will look like this. So binary will look like this, main. So this is the binary. In the Windows it will be .exe, in the Linux it will be like something like this only. And once this is completed, and this /main.go like specifies the source code like this main.go file only. And then what we are going to do here is we are going to give the permissions, like executable permissions, to the file that we have, binary we have created, main. So we are going to give the permissions here. And once this is completed, now we have to expose a port also from the Docker. So we are exposing a port Docker like 4040. You can expose any other port as well. And the other way, now once this is completed, we can just run our main file in the Docker container with like this /main. This is our Docker file here. Now what we need to do is we need to create a workflow file, right? Once the Docker is completed, we need to create a workflow file. So for that we need to create a new folder .github, and under that we are going to create one more folder which will be workflows, and under that we are going to create a file cicd.yml. all right, and for that we can name this workflow as, suppose, like deploy go application. All right, so here, like when this workflow should be triggered on the push event of this particular branch of this repository and this branch. On push of branches, I will name my current branch here, which is get branch deploy to EC2. You can add any other event as well if you want to deploy on any other event. And here we are going to define two jobs. One is like a build job and another is deploy job. So we'll write that. So build job will be running on the Ubuntu latest, which is GitHub hosted runner. We can use the self-hosted runner as well, but I'm going to use this Ubuntu latest. You can register your own runner and you can use that as well. And here we are going to define few steps here. So first step will be like checking out the source code in the Ubuntu this runner, GitHub hosted runner. So we'll name it as checkout source, and it will use this action /checkout @v4. all right, and after that we are going to create a environment.env file. Since this is not we are not going to commit this file, we have port details, like this is dynamic port allocation here. So we need to give like this is for like reference that how you can store the secret informations like as a environment variables in your application. Since node, you see, like you create a .env, so here also we can create a .env and we can store all this information there. How we'll see there right away. Like we'll create a .env. Suppose you have multiple parameters, so you can add all this details in this file. You can add this detail in GitHub secrets and you can access them right here. So let's see how you can do this. So we'll run a command like not the Docker one here. We will just echo and port, since we have just port only. And how we are going, suppose like this is secret details, I don't want to expose, like how we'll do this from the GitHub secrets. So we can access it from the secrets dot port. Okay, so we need to add this detail in the repository secret here. You need to go to the repository settings and you click on the security section and secret and variables, click on actions, you need to, I have already added, so you can click on new repository secret and you can just add a new repository secret like this. It will be added here, and I will write this in the .env file. So this will be created at the runtime. So here you can manage these details right away. And once this is completed, I want to log into the Docker Hub and I will deploy this. So in the Docker Hub also we need to create a new repository. I haven't created it yet. Go -app, I will just create. I will just mark it as public. You can make it as private as well. I will just create this. So this is my repo. Here I need to log into the Docker Hub. So I will just write this command, docker login -u -p. So -u, we need to add the password here. Okay, so let's write it. I will access these details from the GitHub secrets I have already added. You can also add your details like this, so it will not be accessible to any other person. And the password also similarly we need to write it here, secrets.docker password. And now once this is completed, now we need to build the Docker image. Build Docker image, and after that we will just run this command, docker build -t, and the name of our image is this one. So we'll copy this and we'll build the image from this current directory. So once this is completed, we are going to push the image to the Docker Hub. Alright, so how we are going to do this is docker push and this integration ninjas app, and we can name the image tag as the latest one. You can use the GitHub commit ID as well, like .github.sha as well for the unification. I'm just writing as the latest one for this tutorial. You can write it like any other way. You can give any other like random things there. So mostly like github.sh is preferable. So I will just name it as latest here. So we have completed our deploy job. So once this is completed, we are going to write a new job, deploy job, which needs the build job to be triggered first, and it should be running on the AWS runner, AWS machine, like the EC2 instance. So how we will going to access the EC2 instance? That's a tricky question here. So we are going to register a GitHub self-hosted runner on our AWS EC2 system. So let's see how we can do. We go to the AWS, click on the EC2. We need to create EC2 instance as well. Let's create that as well. Click on the launch instance and just name your like EC2 instance like go-app, and just click on the Ubuntu runner, and we'll use the free tier eligible instance only, and we can select a key pair to securely connect to your instance. I will just add this. You can create if you haven't created, you like this, and we'll just leave other settings as it is, and we'll click on the launch instance. So once this is completed, we can access the instance like this, and we'll go to the security section. We'll edit the security group inbound rules. We need to enable the 4040 port because that we have enabled in the Docker file. So let's do that right away so we don't forget that at the end, and we should not run into the problems. So this is completed. Now we need to access our EC2 instance. We can click on connect. You can log into the putty and you can log in from the terminal as well. I will just connect from the browser itself. I will just, for this tutorial you can better like use terminal or any other thing here, so I will just access it right here only. We need to install Docker here. Currently Docker is not installed here, so I have prepared a command, so I will just use this and the Docker will be installed. It will install the necessary information apt update and install the Docker, and will start the Docker services with the required permissions. So I have added the script here. I will just add this script details in the YouTube video as well. So once this will be completed, we are going to register the runner. We will click on the actions and the runners, and we'll click on the new self-hosted runner, and we'll click on the Linux system, and we need to follow these steps here. So let's see if this is completed. Yes, this is completed. We can see the Docker PS, there is a thing, and the Docker version. We have these details, so that's fine. And now we need to create this runner, register this runner. So let's follow the steps. We need to download this package, action package, and we need to unzip it as well. So let's do this, and after that we need to start the configuration process for this repository. So let's do this. We'll just name the runner as EC2, and we'll just any additional label you can add. I'll just skip, and the work folder is default underscore work. That's fine. And after that we can configure, run this as a /run.sh. all right, and we can see the runner is started here. So we see the runners here, so I will just click here, runners, and we can see the runner is up and running. But what if I see the Docker process and the other things on this terminal? How I can access the the runner will be stopped here. If you see here, runner is stopped now. So I want to start it as a service, so it run in the background. We don't need to start again and again. So let's do this. How we can do this? We need to install this service here with this command. Once this is completed, we need to just run this thing here. That's it, and the runner will be up and running. Okay, so this is completed. Now these are the two commands here. We need to install the service with the following command and need to start the service. That's it, and the server is up and running. We can now do any other things in this terminal as well. Okay, so now we have access to this. Docker is installed, so we are going to use this EC2 instance. We are going to use this runner here. So our job will be running on this self-hosted runner here, and here what we are going to do, we are going to write some steps. That first of all we need to pull the Docker image, and then what we are going to do, we are going to run this command for docker pull, and the image name with the tag which image we need to pick up. So once this is completed, the image is pulled in the Docker system. We will just run this as a Docker container, run Docker container. So let's correct this, and for this we are going to run this command docker run -d-p, since we have enabled 4040 port and we are listening on that from the inbound rules. We are going to use this, and we'll just name our application as container, Docker container as go app container. All right, and we'll just name the image here. That's it. The container will be up and running. So suppose if we have already a container running, so we'll just delete that container. So in the deployment case it will become we can delete the old container if exist. For that we'll just run this command docker rm-f, and this container name will delete this and will redeploy if we have already this Docker container. So that's it. These are the commands here. So we'll just deploy this now, and let's see if this is working or not. We'll just commit this details, git commit test deployment for AWS EC2, git push, and let's see if the actions is getting triggered or not. Okay, yeah, this action has got triggered here. So we see there are two jobs, build and deploy. So first this will be completed, then this will be completed. So let's see the build job. The login to the Docker hub is succeeded and the Docker image build is in progress. So this is also about to complete. Yeah, this step is also completed, and the push image to Docker hub. So once this is completed, okay, there is like a manifest lob unknown to registry. There is some error probably. Okay, we'll see this, like what is the error actually. Docker push go -app :latest. Yeah, this is the correct one only, but let's see why this got failed. Pushed errors manifest blobs unknown. Let's see if the image is there or not. No, there is no image. Manifest blob unknown to registry. It seems like there is some error. Let's try to see. Let's see if there is any issue in the Docker file. Where is the Docker file? We have everything working fine here. Let's try to short it down, and let's see. Okay, we have this go app, and we have copied this go.mode, and then we have go mod tidy, and we are copying the source code, and we are building the application, and we are giving the executable permissions. Should be working fine. Let's try it once again. If there is some network issue or anything, we'll be able to try that. Okay, ideally it should not fail. Let's wait here and see the push process here. Push image to Docker hub. So the build is already success. If there is some issue, it should fail in the build itself. The push is little failing. Okay, this is also completed, I guess. Yeah, maybe there is some network latency issue. Now, well, let's go to the deploy job. The pull image from the Docker hub is completed. We can see the image is pushed here right away. So the image is here a few seconds ago, and the pull Docker image is completed. Since there is no Docker container, it returns exit code, like it's not processing, and the Docker is completed. The container is up and running on the port 4040. Now we can go to the public IP4 for this application, and let's try to access from the 4040. And yes, we can see hello from GoLang API, right? And let's try to access the other APIs. We have one items API. This is also working. We have one more API, random user. This is also working, and there you have it. So we have successfully deployed a GoLang application on AWS EC2 instance using the power of Docker and GitHub Actions. So the automation is the future of software development, and GitHub Actions make it easier than ever to streamline your deployment process. I hope you found this tutorial helpful, and I will give a try to create more videos on such things like deployment and the other configurations. I hope you enjoy this. If you found this video helpful, please don't forget to like, share and subscribe for more tutorials like this. Thanks for watching, and we'll see you in the next video. Have a great day.